When approached some short time ago about sharing the experience our company, people in our industry had when getting public transportation to gas, there were two reactions from my side. Number one, it was very short time to prepare. Number two, knowing the Israel environment for a couple of years now, understanding that there are certain challenges in this environment. Number three, being thrilled to participate, to share the experience of introducing natural gas, compressed natural gas to the public transportation sector. The last emotion overweight, and I agreed to come here. And today I will present a little bit what is going on globally, what are the new developments. I will tell you about a lot of challenges we have seen in our industry, and I hope that you find time to raise questions, and I will try as good as possible to answer any queries you may have. We are going through today, to give you a little bit of background of the company, we are looking at global trends CNG buses have taken for the good and the bad. We will compare in a few words CNG to diesel again. We will look into international design standards which are there to regulate CNG vehicles and CNG storage, which is typically the most critical, the most costly part of a CNG vehicle when it comes to the powertrain. We will look at lessons learned in this industry. I will have a few words about risk mitigation in an exposed environment, operating pressure vessels on vehicles, and we close with the conclusions. Hexagon Composites is a Norwegian company, a Norwegian stock market listed company, traded on the Oslo Stock Exchange. We have daughter companies in basically three major areas. One is high pressure natural gas tanks made from composite, fully composite, Type 4 tanks. We have a company operating in making composite LPG household tanks. And we have a company which is busy in the field of semi-fabrics for composite structures like windmills and ships. The company today is globally present. We have manufacturing plants both in the US as well as in Norway. We have partners, assembly partners in Southeast Asia, and we develop our business basically between Indonesia and Peru if you look from the east to the west. Major markets, of course, are Europe and the United States of America. The United States has seen what you are in the beginning to experience, a revolution in the utilization of natural gas due to the shale gas available there. And in foreseeable period, the US will have both the leading amount of natural gas in the world, as well as they are also developing the leading technologies to utilize it. The company is basically set up to cater all areas of compressed gas storage, both for natural gas vehicles as well as for gas transportation. We do natural gas vehicle and storage systems for 200 and 250 bar service pressure. The difference I will explain a little bit later. We are the leading supplier of hydrogen vessels up to 950 bar service pressure. We do tank containers and road trailers for CNG and hydrogen. And we have stationary storage units up to 550 bar, which are used in compression stations. We do hydraulic accumulators both for vehicles as well as for riser tensioning units on oil platforms. And we have been an important partner to the DOE in the US to develop composite riser technology for deep sea drilling. Customer base is basically the leading gas companies worldwide, but also new gas companies which transport natural gas, for example, now in the north of the United States, beyond the pipeline, like NGA. We are with the leading OEMs worldwide, both in passenger cars, like Mercedes-Benz or Opel, as well as in the heavy-duty sector, which is Kenworth in the US, Volvo, and others in the field of building buses. If you look at the way our business has developed since 2005, we have seen exciting growth, and a billion-dollar business for us is now in reach within the next 5 years. We are the oldest company in the field. We have 50 years manufacturing experience in composite cylinders. If you look at the space shuttle, it carries our cylinders. We have 20 years of safe track record in the serial fabrication of Type 4 cylinders for the vehicle market. Looking at the global trends for CNG buses, and I will not go to every country which has a tradition in utilizing CNG in public transport, like Iran and Pakistan or Argentina, which are still one of the largest CNG economies in the public transport sector. I look at the new developments. And the new developments are basically developments which have happened in Europe, starting from France and Italy. In the early days, the major focus of the business, the major focus of using CNG in public transport, especially with the introduction of low-floor buses, has been to Scandinavia, where we also operate under very, very cold environments, especially with Sweden and Norway entertaining biogas to a large extent. It has been Spain, which is one of the leading areas in the world now utilizing CNG buses in very hot climate in public transportation. If you look at Madrid, Barcelona, all of these big cities have a majority of CNG buses now. We see strong trends to CNG in Turkey. Also the Turkish bus OEMs have been preparing for CNG. They offer CNG buses today. And amazingly enough, the new EU members in the East are employing CNG, mainly because their infrastructure was run down and they had to restart the entire operation of public transportation. They have been choosing CNG buses for the new investments. But I think we should also realize that initial experiments or initial experience, especially in France, led to the fact that France today has halted some of the CNG development. What happened? CNG was in France, well, France was an early adopter for CNG. There had been a lot of rules implemented complicating the scenario dramatically. Italy, for example, has introduced many, many years ago a re-inspection scenario for all CNG cylinders on all CNG vehicles, where you are forced to dismount the cylinder from the vehicle every 3 years. The cylinder is shipped to a central testing agency. The cylinder is basically exchanged with another cylinder whose history is unknown to you as the user. So you basically face that every 3 years you have to stop a bus or a private vehicle. You have to allow the CNG system to be dismounted from the bus or from the vehicle, and you get another set of cylinders being mounted to the vehicle, which history is basically unknown to you. This is a scenario which, under today's regulations and technologies, is completely unnecessary, but it is a fossil dinosaur which is still in the market and which basically has made many municipalities in Italy to rethink to invest into CNG. But in general, the trend is reversed. Euronorm 6, now valid in Europe, has basically made CNG buses competitive again versus their diesel companions. The exhaust treatment systems under Euronorm 6 for diesel basically bring a solo bus or an articulated bus into a price level which is very close to CNG. And now CNG still has the advantage of lower fuel cost, even giving the needs for compression, the cost for compression. It has become much more competitive again in the European environment. But there is challenges. The challenges are that we see in some countries still very high gas prices. Sweden, for example, the gas price is extremely high. They compensate through the use of biogas. We see shifting politics in Brussels. I mean, if you look at the utilization of CNG under the European environment, CNG was considered a fossil fuel for a long time. So it wasn't subsidized, or it wasn't strongly promoted at all. Then the electrical hype set in. Everybody wanted to drive electrical buses or hybrid buses. Volvo bus, for example, left the field of CNG buses and is now exclusively offering diesel and hybrid buses. Now, as a matter of fact, CNG buses are much more competitive than hybrids, but with shifting energy taxations, with unclear political rules, and with re-inspection scenarios like in Italy, the CNG history has not been a full success in Europe. Estimated CNG adoption, therefore, is also what my best guess is about 5%. The adoption is basically determined by the fact, what do you really call Europe? What do you really call a CNG bus? There is still tons of old converted CNG buses in some newer parts of the European Union. But if you look at modern city buses, in Spain adoption is very high, up to 50%. In Germany adoption is very low, I would say less than 2%, but in average the 5% may be right. The major motivation now to promote CNG on buses is to get to a CO2 neutral fuel, and biogas is such a fuel. Biogas basically made out of biological waste, be it meat, be it sludge, be it brewery residuals, has become, especially in Scandinavia, a strong trend. And if you look at the CO2 balance from well to wheel, it can even have a negative CO2 balance due to the benefits of utilizing this in terms of natural digestion. The United States always have been a strong country for CNG buses, and if you look at especially California with their stringent exhaust regulations, CNG buses have been a strong part of public transportation economy in the United States. The US, different than Europe, is letting the market decide what is the best fuel. In the US there is a limited amount of regulations. In the US there is a very low price due to the shale gas revolution for natural gas. And if you look at municipalities today, as long as they can have a budget, which is not always given, they basically invest into gas buses as long as they already have a prior infrastructure to fill them. New York City recently has adopted CNG in a large amount. Traditional cities like Atlanta, Phoenix, Arizona, Seattle, and especially the Los Angeles area are running CNG buses by the thousands. The further argumentation in the US to use natural gas on buses and also on heavy duty, in the overall heavy duty sector, is that natural gas has become a national fuel source. Natural gas is preserving and creating American jobs, and it has lower cost to meet emission standards. So the grand policy has been careful. The US is not subsidizing overly much, but in general, the price of the fuel is determining the success of CNG in the country. So early 2013, we saw about 35% adoption of CNG in public transport. An amazing story, like in Israel, is forming in Russia. Russia has realized that with America competing in future substantially on liquid natural gas for export, they see that larger amounts of their natural gas must be used inside of the country. So we see large infrastructure programs being started. Everything takes a little bit of time. Russia is a big country and has still a lot of bureaucracy, but there is a true effort to get there. First bus projects have been taken into account. The CNG buses for Sochi came a little bit late, but we believe that the only challenge Russia today has is not the availability of gas, but the challenge is that high import tariffs presently prevent the large-scale importation of CNG technology, and so Russia still depends on local resources which are not always satisfactory. So that's one thing which we are discussing with the Russian government, to at least, like Thailand, temporarily for 5 years or longer, allow low or no import tariffs for CNG equipment until we have built up the local industry to produce this kind of products. India is another story which has been fascinating. I'm visiting India for 30 years of my life, and from the decision of the Supreme Court in close to 2000 to make CNG mandatory in all public transport, taxis, rickshaws and buses, New Delhi has become a new city. If you visited New Delhi 10 years ago and you come today, the air quality is a fantastic difference. And I think India has done very well in a planful, step-by-step approach of CNG to major municipalities in the country. India tends to overregulate, and the CCOE, the Chief Controller of Explosives, is still today a challenge for the industry, and India is also raising CNG prices. Taxation and instability of CNG prices is something which our industry is extremely sensitive to. Southeast Asia and Oceania, Australia, New Zealand, Thailand, Indonesia are both going again for large tenders in CNG buses. The Trans-Jakarta is one of the successful projects in the regions. They unfortunately had chosen initially unfortunately gave too much way to the Chinese suppliers to supply sub-quality equipment, so they have seen several explosions. The same, by the way, in Korea. We believe that the new way they define the tenders take care of these issues, so there is better quality coming ahead. Australia is the opposite story. Australia had seen a quite large adoption of CNG buses in Sydney, Perth, Brisbane and Adelaide. They had basically a one supplier situation on their CNG storage. Then they saw explosions because that supplier, which in the meantime is bankrupt, comes from Germany, has delivered products which were substandard. And it came so far that the Sydney bus drivers said, no, we are not going to drive these buses any longer. So they were on strike. And the situation today is that basically all of these systems will be shifted out. So Australia has therefore a quite, let me say, different view on CNG. They are trying now to repair the mistakes they made initially in the way they specified and have chosen their equipment. So the quality of what you put on buses which have a high visibility and high publicity if things go wrong is a very, very important thing. Australia is to one extent a quite good comparison to Israel because Australia is having very high temperatures. CNG engines in the past or bus engines in general, also diesel, have always had a tendency to dislike a little bit high environmental temperatures. They easily start to burn for several reasons, which are not dedicated to CNG, but to the way these kind of buses are constructed. The Australians have made very good studies about the behavior of buses in general in terms of fire, And you see on the right side the claims, the number of claims insurance has got from bus fires in general. This is not related to CNG, but why a bus fire is so important to look at for a CNG bus we come later to. General infrastructure development. If you see how CNG develops, compressed natural gas in the vehicle industry, then you will always see a pretty much the same pattern. You will start with urban fleets. These are transit buses. Then you will see some centrally organized heavy-duty vehicles, fleets developing, mainly refuse trucks. To some extent, the large trucks, class 7 and 8. Then the light-duty fleets follow, taxis, delivery vans, and then quite some time after CNG has been introduced to a country, typically the private light-duty vehicles follow suit. If you look into the situation for the private sector now in Asia, it's one of the leading areas due to conversions done in the country. If you look into the European sector, we have Volkswagen, we have Mercedes, we have Opel offering beautiful CNG cars, but there is very little amount of people buying them due to missing infrastructure for refueling. If you look at the United States, I remember 4 years ago or 6 years ago, before the big crisis or within the big crisis of the large three, I always said, well, I don't understand why the US is not keeping their large-sized vehicles with their large-sized engines, because they are extremely well suited for running on CNG. And the government should make sure that they get enough CNG filling stations to run this kind of vehicles before you start to sell to an American Volkswagen size. Now, in the meantime, I'm not laughed at any longer, so the way the things go into the right direction there. CNG versus diesel. I would say that the biggest advantage of CNG is the lower fuel cost and the little amount of effort which needs to be done to make this a real clean vehicle. You have disadvantages: cost of compression, maintaining a compression station. Brussels, for example, Brussels at one point of time decided against CNG buses because they had to install a large compressor station. So cost of compression, installation of compression can be a disadvantage. You have also, and this must be very clearly mentioned today, a different safety approach in how to operate these kind of fleets. Diesel has the advantage of an established fuel. Life cycle costs at Euro norm 6 are getting higher, but I would say that the most important factor, especially for the US and eventually for Israel, is the dependency on a fuel which is coming from areas which are not always kind to us. Looking at the international design standards, we have basically two areas in the world when it comes to compressed natural gas use. One area of the world says, and that's the majority, says 200 bar service pressure at 15 degrees C is all we want to see in our tanks. These areas are basically covered by the ECE R110 in Europe and the ISO 11439 as an international standard in most other countries. The only exception is North America. US and Canada are running the NGV2, and the NGV2, by the way, ECE and ISO 11439 also allow for higher pressure levels, but the North American market is basically running all kind of vehicles at 248 or 250 bar at 21 degrees service pressure. It's just a matter of definition of the reference temperature, so don't be disoriented by it. Now, what is the advantage? The advantage is that I believe the US-Canadian system is a little bit smarter, because at minimal higher cost they put more gas into the tank, and that is as much as nearly 20%. This is not irrelevant and needs to be considered. On the other side, Israel is very close to the European market. If you import vehicles, both on buses as well as on the private sector, it is mainly European vehicles which come into account here. But I would like to bring the matter up, as long as you are still in the greenfield stage, that 250 bar surface pressure is an advantage of 20% fuel density. So it makes the cost of operating a vehicle lower without sacrificing safety. What is the difference between these design standards? You will find that all of these design standards basically refer to pretty much the same principles. If you see the test scenarios, the certification testing between all of these standards, they are insignificantly different. The factor of safeties are insignificantly different. The lifetime of the cylinders is is the same. There is some differences in the periodic reinspection. But I had a very interesting discussion with one of our quality engineers a few years ago. And I said, why is it so different? I mean, what is the essence of difference in the European and the US thinking when it comes to design standards? And this young man explained it to me very simple. He said, the European mentality is that as long as you design to a standard and you don't violate it, any accident does not cause you as a company or as an individual to suffer from it. There's no legislation because you have kept the practice of the industry. In the US, following a standard does not excuse you from being subject to legislation in case something goes wrong. This is why we also see a little bit more conservatism within our US colleagues in pressure vessel building than with our European ones. Periodic reinspection, and I think we get to that. There is different, let me say, regulations, thinkings, standards in the world. Reinspection is very important because reinspection makes sure that your vehicle after 3, 5, 10, 15 and 20 years is still in a safe condition. The best practice I have personally found in this industry is still described by ISO 19078. ISO 19078 is applicable to gas cylinders, inspection of the cylinder installation, the requalification of high pressure cylinders for onboard storage of natural gas as a fuel for automotive vehicles. And by the way, I would also apply it to trailers, to gas transportation, because it's a very smart standard. It clearly defines in what cycles reinspection has to take place. And the government, the local government, can still adapt that period. So the German government, for example, does reinspection according to ISO 19078 with each biannual reinspection of the vehicle. And it also determines other conditions when you need to reinspect. For example, if a vehicle has been through a collision. It defines what is a qualified inspection body. TÜV in Germany, TÜV Rhineland, is, for example, making great strides in Dubai to train and educate inspection bodies to make sure that the country in future has a safe CNG vehicle park. Different than the Italian approach, it prohibits the disassembly for inspection for all kinds of cylinders, even Type 1 and Type 3 cylinders, which have metal cores and theoretically are subject to fatigue. The thinking here is that disassembling a cylinder from a vehicle and reassembling it basically bears stronger risks than leaving the cylinder on there and just inspect it from the outside. And it prohibits hydraulic retesting. Hydraulic retesting comes from the old age of steel cylinder. A Type 4 cylinder with a polymer liner and a carbon fiber cover simply cannot be rechecked by expansion volume. It has nothing to say. But broken fiber, which you see from the outside, is a very clear sign that the cylinder should be taken out of use. Concentrating on buses, on public transport. Here a quick overview what is part of a CNG, compressed natural gas bus tank system. You have the tanks typically on the roof. With low flow buses there's no more space to put them under. You have high pressure piping which on one side leads to the fueling receptacle where you can fill the bus or the storage, and you have the other side going to the CNG engine, which basically ends up in a pressure regulator where the pressure from the CNG system, typically from 200 bar or 250 bar down, is regulated into about 9 bar, which is required in the engine. The safety issues here are basically design and structure related, choice of equipment, system design and interaction. There can be risks in the operation. A typical failure mode we see is gas quality, and there can be fire and accidents. If you look at a CNG system as a roof system, it basically consists of a frame. The frame holds the cylinders according to regulations defining the behavior, how that frame has to hold the cylinders under strong G loads. You have cylinders which are equipped with solenoid valves, which basically shut off the gas supply from the cylinder once you turn the key. And you have what we call temperature-triggered pressure relief devices, which trigger at about 110 degrees C and relieve the entire gas out of the cylinder. This is a very important point when we come to running CNG buses in public areas, because that relief of gas in case of fire, in order to avoid explosions, is what often gains too much publicity. There is a choice of cylinders you can make, and I believe that all kinds of cylinders from renowned manufacturers are very good cylinders. In coastal areas, I would stay far away from Type 2 cylinders. Type 2 cylinders are cylinders which have a steel core, which are made lighter to save weight, and which are typically in the cylindrical sections are wound over by glass fiber. The problem of these cylinders is different fatigue between the steel contracting and expanding and the glass fiber doing the same over time. At one point of time the glass fiber is getting a little bit tired. You get micro delaminations and you see humidity creeping under the composite, and then you get rust stains, and the cylinders as early as 3 to 4 years after they have been installed start rusting and cannot be repaired. Type 1 and Type 3 in some circumstances by manufacturer may require hydraulic retesting, and I would be extremely careful to look into hydraulic retesting of this kind of units, because it requires a safety infrastructure or a testing infrastructure in the country, which is quite complicated. Mounting of cylinders is very important. The upper picture shows, by the way, Type 2 cylinders, I believe in Australia, mounted by straps. The lower picture shows the same different cylinders mounted on their necks. What is the basic difference? The basic difference is that any mounting system with straps requires an intermediate layer of rubber between the steel and the cylinder surface, be it steel or composite. Now these rubbers have the disadvantage that they disintegrate over time. UV, especially UV radiation, makes them soft. If reinspection is not done thoroughly, you see the steel suddenly rubbing on the surface of the steel or the composite cylinder, and by that you are inviting explosions. So that's not a very good way to fix cylinders. The better way is to fix them on neck mounts, which basically allow also a turning of the cylinder, a determined turning of the cylinder during optical reinspection. The other thing which needs to be made sure that cylinders can expand thoroughly. Typically you have 0.5% expansion in diameter and in length, and when you fix a cylinder to a structure, you want the high pressure piping being fixed to the cylinder, staying at the point where it is, and you want to expand the other side of the cylinder so that the piping remains stationary. You can have different ways how you mount cylinders. The typical or the traditional ways is either transversal or longitudinal. Transversal has been the choice of the industry for many years. The biggest benefit is you have very easy access to the side of the bus. You can take a ladder and you can re-inspect the valve side or the PID side of the cylinders. You see it in this picture there. The transversals is cost and the disadvantages are cost and weight. You have more connections to maintain. And there is basically two kinds of impacts I see in this industry. One is that the bus hits a bridge or gets stuck into the tunnel. By the way, the fire marshal of Stockholm called me a year ago, and he said, Mr. Heiberli, I have an urgent question. We have a CNG bus with your roof system on the top, which has entered the Klaraberg tunnel. It's a tunnel in the mid of Stockholm. Now, unfortunately, the driver was not aware that the tunnel is 10 centimeters too low for the bus. Now, the bus is sticking in the tunnel. We have not lost gas, but what do you recommend us to do? I love this job. I mean, things like that are fantastic. Now, what you basically can say is, number one, you need to get the gas out of the cylinders. It's a good sign they didn't leak, but the question is, how do you get the gas out of the cylinders? We are getting there. The second thing is, how do you get the bus out of the tunnel? We come back to the answer of that question when we see the pictures. Think about it, how you would do that. The longitudinal ones are, as I said, lighter and less costly. They can build sometimes smaller at the same volume. Most important is the impact scenario. On front impact, I like transversal cylinders because they are basically with their long side very well suited to run into something and not leak. If you hit longitudinal cylinders from the front, you basically need to ask the question, any safety device which is on the front of the cylinder may be hit under that impact and may start leaking. Australia has the different challenge. Australia has a lot of low-hanging balconies, like Holland also. So here the typical accident is that the bus tries to get around a corner, and then a balcony basically takes off a whole row of CNG valves, and that also has some interesting effects. So it's a little bit, let me say, it's a decision you have to make. What is the major threat in your country? If you have tunnels, if you have bridges, then I would go for a transversal. If you have mainly that side impact trees, etc., the longitudinal is the better choice. We had a case in Strasbourg some times ago. I mean, European gas, or gas in general, besides some parts in Asia, is very good. Gas quality by itself is a very constant, under very constant conditions. But suddenly we are getting calls from the Strasbourg municipality telling us that the valves start leaking. Okay, we buy the valves from a renowned manufacturer, and we also learn that we are not the only ones having problems. There's other cases too. So everybody is now going to Strasbourg and trying to find out why are suddenly the valves leaking. Now what happens is that we suddenly find ester inside the O-rings, which are basically sealing the valves. Ester, which has no place in it because neither natural gas nor normal compressor oils contain ester. So what we found out, a new compressor oil was used in this case. It was most probably diluted in the gas. Some of the older compressor stations still leak a lot of oil. Or the other assumption is that cleaning agents used in that filling station had not been checked thoroughly, and residuals of that cleaning agents are in the gas. Again, I don't want to over-dramatize this situation. Out of hundreds or thousands of compressor stations worldwide, there's proper operations. This kind of exercises come and go. Everybody learns in the industry. But you see the difference this kind of ester makes on the O-rings sealing the valves. This was a recent one, and I believe this was most likely the most awakening one we had in the industry. If you go back to that picture here, you see that there is valves mounted on the front side of the cylinders, and there's valves with PIDs, and there's also PIDs mounted pressure relief devices to the other end of the cylinder. These pressure relief devices are completely in line with the standards, directing horizontally out of the cylinder. Now what happened here in Den Haag in Holland was that a bus caught fire, and this goes very fast. Number one is the drivers see late that there is a fire developing. Typically they are warned by other traffic people that there is a problem with the bus, both for CNG and diesel buses. So the fire typically starts in the engine compartment, and then it develops quite fast, because different than on airplanes or on ships, the regulations for fire retarding materials in buses are not very developed. So the bus is pretty much getting very fast in full-fledged fire. And then the pressure relief devices, temperature triggered, relieve the gas. That is what they are supposed to do. Now what nobody in the standard foresees is that with a horizontal arrangement of transversal cylinders and a full cylinder, there can be quite a jet of flame going out horizontally. This is what happened here in Den Haag. The other thing is that any evacuation of gas in a burning bus is typically considered by people watching it as an explosion when it comes to interviews in the television. So you need to be prepared when you operate municipal buses with CNG that these kind of evacuation procedures typically attract a little bit of publicity. So what did the industry learn out of that? The industry learned out of that the direction in which the gas has to be evacuated out of the cylinders preferably is 90 degrees up, so that you have the gas evacuating to the top. And by the way, it is not always given that the gas also really ignites, because the gas stream is very cold and very fast. So in good cases you would not see that kind of behavior. That the bus burns down is, by the way, very common, especially for diesel buses. Lessons learned here: PIDs directed right and fire marshals must be trained to handle and to understand when a CNG bus burns. For example, that preferably you cool down the CNG system until the bus has burned down, and you know that there may be jets of gas developing during the evacuation of the gas. Impact. Impact has been frequent, and I must say there is very, very little incidents where impact led to leakage. And I don't know of one incident where impact led to any explosion. Impacts are typically caused by bridges, tunnels, corner edges of balconies, or crash with other heavy-duty vehicles. And as sad as these incidents may be, they give our industry an ideal test bench apart from qualification testing. In result, as I said, I have basically very little systems seen leaking. The rescue teams need most of the orientation because they are uncertain what to do with a bus who has been, for example, crashed into a tunnel. And of course the situation again attracts publicity. Very important is the regular inspection of the cover which is around the CNG systems on the buses on traces of impact. That rule was violated in Australia. Australia has seen systems which had prior impact before, which had not been detected, and a year or half a year later the cylinder system started leaking or rupturing because at one point of time the prior impact led to weakening of the cylinder. And very important is also the immediate condemnation of involved cylinders. We have seen cases where type 2 cylinders reinforced by glass fiber had been burned down on buses, and some intelligent people basically resold them later as type 1 cylinders with fatal consequences. This was the one we were thinking about. So how do you get a bus out of there once it has been squeezed into a tunnel? The simple answer is yes. Release the air from the tires and you gain another few millimeters. So this was an accident where a bus hit, I would say, roughly with 50 kilometers per hour. This nice installation here, you see how much the steel frame is damaged. None of the cylinders leaked. We had a little leak because one of the PIDs got hit, but there was absolutely no dangerous conditions in this accident. And this speaks for many of similar accidents where like in this bridge impact, where CNG systems have been heavily impacted by either from the bottom or from the top. This one went fatal for both bus drivers, but it did not affect the CNG systems. The CNG systems stayed tight. That was an accident some years ago in Germany, and that was on a street along rather high speed. You see the amount of damage which was caused to the buses. Lessons learned. CNG. CNG is a very safe fuel, 50% lighter than air. It dissipates quickly when admitted into free air. This is the major difference to LPG. LPG is going down. LPG forms a very violent mixture with air which can be easily ignited. CNG has a very high ignition temperature, at about 630 degrees C. It has a very small flammability range. Igniting CNG needs 5 to 15% contents in air. And it is a non-toxic gas. I mean, I wouldn't advise to sniff it regularly, but it is a non-toxic gas. In result, natural gas is a proven alternative to diesel as an independent fuel source for city bus fleets, being low cost, very safe, and by nature clean. This is, by the way, the Oslo Opera with a Solaris bus in front. Bus fires remain the probably biggest challenge for CNG buses. You have multiple sources for fires on buses. One is the engine overheating, especially the new lean engines with a lot of SCR systems, the exhaust systems getting extremely hot. So that is one source. The other source on CNG buses can be a leaking pressure regulator, where gas basically is allowed into the engine room. This has been prior issues with the installation of solenoid valves shutting off the gas from the pressure regulator once you stop the bus. This matter has been pretty much come out of the situation. We have this case that fires are noticed late. Fires can basically also happen in the bus depot. So when you have buses standing side by side overnight and you have one bus getting on fire, this can have quite dramatic effects, both on diesel as well as on CNG buses. They are fast spreading. We explained the reasons why. And they cause the CNG system to vent typically in a quite spectacular way. So we need to look at the design of buses. One case we had many years ago was the fact that the emergency exit opening on the roof was very close to the CNG system. Now the bus was standing in a depot overnight. The engine caught fire, and the CNG system, which had the PID system on both sides of the cylinder, transversal, was of course designed for taking the fire through the windows, detecting that, and then relieving the gas. Now, with the driver having the emergency window open, the fire didn't take that way. It took the way through the emergency window and then basically cut the front cylinder just in half. So that piece went quite far in this case. So that has been addressed in the industry by also placing pressure relief devices strategically around the system so that you do not have these kind of cases. So design of buses is very important. Not every bus, like not every cylinder, like not every car, is the same. You need to carefully specify the bus and listen to everybody in the industry. The design of bus depots. I can tell you a story from Den Haag in Holland, where after they bought 200 CNG buses, at one point of time the fire marshal in Den Haag said, "Wait a minute, did somebody ever ask me what happens when there is a fire in the bus depot?" I believe the fire marshal should have been involved into the decision making before the buses were bought. I think you get people along, you get competence from other areas which you need when making such crucial decisions. Training of fire marshals. We have had great success with that also in gas transportation. For example, in the US, the fire marshals of New Hampshire at one point of time wanted our large trailer solutions to have a pneumatic shut-off system to basically stop the flow of gas by a central function wherever in the plant. I believe this is a very important safety issue on a trailer. We learn from them, and an early discussion can avoid a lot of trouble here. And very important, the training of the bus drivers, so the guys just not run away when there is a fire. Important is that they turn off the engine, that they evacuate the bus properly, and that they do the necessary steps to call and inform the fire marshals that we have a gas bus here or a diesel bus. I've been asked many times in Israel about the opportunities to mitigate the risk of an explosion of a CNG system on a CNG bus in case of the unfavorable event of a suicide bomber entering the bus. And I believe that especially Israel is in the unfortunate situation that this cannot be completely ruled out. So we are talking basically about a high-energy multi-small metal element impact from inside the bus, if I describe it in a very nice way. And I was asked how Hexagon Lincoln, with 50 years experience in the defense and composite pressure vessel business, would be able to prevent a situation that the explosion would lead to a lot of debris flying around, because I believe that is the major concern in this subject. To be quite honest, at this point of time, I know there have been practical trials which have not been successful, not with our cylinders, with other cylinders. I believe that the benefit of a composite cylinder is that it can be designed a little bit to purpose. But my general approach here is that I can basically say that there's two ways to success here. One way is that we basically get into a situation that we are using ballistic materials, ballistic proven materials between the bus and the system to bring down the speed, the impact energy of the small materials, small metal elements. Always remember, the certification of a composite or any cylinder involves a shotgun test. So you basically shoot at a fully loaded cylinder, and the composite must not fail in terms of explosion. So composite cylinders are prepared for impact of projectiles and need to stand that impact. But if there is a multi-element impact, then the question is, of course, what happens. So I have basically two approaches in thinking here. One is to protect the system from high velocity impact, because lower velocity, lower energy impact will be very well taken by this kind of cylinders. The second option we have is that we look into separating the cylinders and not build them in solid packs on the roof, but alongside the corners of the bus. This would further reduce the exposure to a rupture of many cylinders at a time. Something we need to be realistic about here is, however, that any bus manufacturer would most likely have greater issues with building a special system like that. Bus manufacturers are not known to be the most flexible companies in the world in making special applications for their buses to specific environments, especially not when it comes to gas systems. So I would believe that probably the approach of looking into a ballistic protection is the most promising approach, because that can be easily integrated into the build of the system, which is done by sub-suppliers like us. Another option is to basically develop special top layers for the cylinders, which have the same effect. But again, you are getting into a very specialized exercise here, and that can be limiting to the way these kind of buses could be purchased. This is in general a remark I would like to make. I have been talking to many players in the industry in Israel, and from gas transportation to vehicle installations. A typical tendency I see here in Israel is to say, well, Israel is special. So we need more, we need better, we need additional regulations, testing, specifications, and other issues which typically in a very regulated world like ours do not always very well fit the concept. I would believe that the international regulations as we see them today, plus the learnings which have been done in the industry globally, have high value also for applications in Israel. And I would like to give advice to not over-regulate this sector, because what you basically do is that you kill the interest of the players in this market to support the application of, for example, CNG in the public transport or in other areas. The Israeli market is too small, seen on a global scale, if you, for example, compare it to the US, to make a lot of specialty products in the CNG area. And remind you, even if you just wind a different composite, a protective composite, over a cylinder shell, you are going to at least $300,000 and 1 year of qualification testing to make that project work. So always be reminded that any specialties, any regulations, any separate specifications you apply may be not be easily followed by the main players in the market. Conclusions. I think we have a very good CNG bus technology now, globally. We have a broad number of capable OEMs in Europe and Turkey who can provide you with excellent CNG technology buses. We are very competitive to diesel. Operations, maintenance, and rescue environment needs to be trained, and I think that is a prerequisite for getting into the greenfield project. Current standards are suitable, and I would definitely suggest consultation of a major third party like TUV Rhineland, who has experience to set up qualified re-inspection, help the government to establish rules how to deal with CNG vehicles on a broader front when introducing this into the country. The CNG prospects for Israel are bright. I firmly believe that apart from gas transportation, which already has started, we will see public transport, we will see trucks. LNG is maybe not the choice in Israel because of the range, the limited range which is required. CNG trucks today in the US run up to 600 kilometers a day. You will see beautiful sporty cars like the Mercedes E-Class, and you will see football moms driving on CNG vehicles their kids to soccer events. I believe all signs are good for a prosperous future with CNG. Thank you very much.